Right. Hello. Hello, everyone. Can people hear me? Just let me know, please. Perfect. So today's an unusual session in a way. We've never done 3 webinars. Well, we've done 3 webinars on physics. Obviously, we've done 3 webinars on circular motion. But when I was thinking of planning the 3rd webinar on complex numbers, I just thought it's better to do a question and answer session. So I hope you brought questions to me. It could be all sorts of questions, not limited to the assignments. It could be general questions about COMPOS. I'm unlikely to answer questions about the university because, well, my only function at the university is I do COMPOS. Yes, I don't teach at university in a way. I'm not the best person to ask about the university. I know some things about the admissions process, but Professor Lwowski will do a session answering your questions about how to apply to Oxford, and I think we might have a recording of one of those sessions. So I'll see if we have that. All right. Okay, so the first question, what percentage you need to score on the 2 assignments to get into COMPOS? Well, we don't know. Short answer, we don't know. And I'll try to post the questions here. So last year, we don't know. We don't know. Last year, you needed an average of 50%. Okay, for both assignments. I hope that helps. 50%. The lowest score we accepted was, but you also you cannot go. You cannot go too imbalanced. So what I mean by that, you can't get 10% on physics and 90% on maths. Okay, you need a minimum of, well, last year we accepted 35. I think 35% was the lowest we accepted for COMPOS. So it was 35, 65. Yeah. So any more disbalanced than that, then it's not. Okay. So I see lots of familiar faces. Not too many people today. This might be a very short session if I don't get more questions. Okay. You can ask me a physics or a math question, preferably related to the assignments, but not necessarily. You can ask me to go through to help out with a particular question. Can you go through de Moivre's theorem? Well, the de Moivre's theorem is yes, I can. Just give me a second. I just opened the maths. Here. Right. Can you go through de Moivre's theorem? So the de Moivre's theorem basically states that if you have cos x plus I sine x to the power n, this could be written as cos nx plus I sine nx. Okay, sine nx. So we can write it. We can actually write it slightly differently, because look, if you have e to the power ix, e to the power ix can be written as cos x plus I sine x. And you can say e to the power ix to the power n.
Are you sharing the screen? Because I can't see it.
Oh, I have. Thank you for letting me know. So this is the whiteboard, and I will share my screen. So share screen. Thank you. And the same thing last. Had the same thing last session. Okay. So I'll cancel this. Look, de Moivre's theorem looks like this. It says that cos x plus I sine x to the power n can be written as cos nx plus I sine nx. Okay. So this is the de Moivre's theorem. Now, do you actually need it? Well, not if you write complex numbers in the exponential form, because you know that any number x plus iy can be written as modulus z. So if you have a complex number z, x plus iy, multiplied by e to the power I theta, where theta is the argument. And this, on the other hand, it can be written as modulus z cos I theta, cos theta plus I sine theta. Okay. Now, if modulus z equals 1, then z can be written as e to the power I theta, correct? Like, because z can, any complex number can be written as z e I theta. And modulus z is 1, so it's just e I theta. And this can be written as cos theta plus I sine theta. Sine theta. Now, if you have z to the power n, you just take this to the power n, and you get e I theta to the power n. But e I theta to the power n is cos theta plus I sine theta, and that to the power n. But on the other hand, you can write it as e to the power I n theta, because if you have a power to a power, then you just multiply the powers. And this, because the formula is still applicable, e I theta is cos I theta. So you replace theta with n theta, and you get cos n theta plus I sine n theta. And this is where, oh, sorry, sine n theta. And the De Moivre's theorem is very useful when you're trying to find, let's say, cosine of 4 theta, the formula for cosine of 4 theta. Okay. So if there are no questions, okay. So for example, you want to find cos 4 theta. All you need to do, so let's say this is what we're looking for. What you need is cos theta plus I sine theta to the power 4 is equal to, and then you do binomial expansion, cos to the power 4 theta plus 4 cos cubed theta I sine theta plus 6 cos squared theta I squared sine squared theta and plus 4 cos theta I cubed sine cubed theta plus I to the power 4 sine to the power 4 theta. This is on one hand, but on the other hand, this thing is equal to cos 4 theta plus I sine 4 theta. And then what you need to do is make the real parts. So the real part of the first expression has to equal to the real part of the second expression. So the real part of this has to equal to the real part of that. And therefore, we can say cos 4 theta is equal to cos to the power 4 theta. This is not real. This is not real. So this is plus, well, minus 6 cos squared theta sine squared theta. Sorry for the handwriting. And then plus, because I to the power 4 is 1, plus sine 4 theta. And then you can use trigonometric identities to get rid of the sine. If you need the answer in terms of sine, you just use sine squared theta equals 1 minus cos squared theta to simplify this into cosine. So Maya, is that helpful at all? So does that answer your question? Or does it help you at all? Okay, yeah, so as long as you remember that any complex number can be written, so complex number of modulus 1 can be written like this, then it's super easy to understand that this thing and this thing are the same. And this thing can be written as this, and this thing can be written as this. And once you get that, really, I want to do another one. I just want to show how simple stuff is. So let's say you need to solve z to the power 4 is equal to, I don't know, I. Yeah, z to the power 4 is equal to I. Okay, how on earth do you do that? Well, there are many different ways, but the best way is to put I into exponential form. So I is, because the modulus is 1, modulus of I is 1, so it's 1 multiplied by e. Now I is pi over 2. I pi over 2. So z to the power 4 is equal to e to the power I pi over 2. But not exactly, because who says it's pi over 2 and not pi over 2 plus 2 pi? I hope you know what I mean. It's it might as well be, instead of pi over 2, it could be pi over 2 plus 2 pi, or 4 pi, or minus 2 pi. Therefore, we have to include all of these answers. It's actually, this is one of, it is one possibility. One possibility. And here we just add 2 pi n. 2 pi n. And that covers all possibilities. All possibilities. And then all we do is we take both sides of the equation to the power 1/4. To the power 1/4. And we get z equals e to the power I pi over 8 plus pi over 2n. And we have 4 possibilities. Z1, the first option, the first solution, is e to the power I pi over 8. Z2, that's when n equals 1. Z2 is equal to e to the power I pi over 8 plus pi over 2, which is for 5 pi over 8. 5 pi over 8. So that's n equals 0. N equals 1. Z3 is e I, so plus pi, so 9 pi over 8. Pi over 8. And Z4 is equal to e I. Now, now n equals 3 in this case. N equals 2. N equals 3. So that's 3 pi over 2. So that's 12 pi over 8 plus pi, so 13 pi over 8. And if you do n equals 4, you will return to your original thing. So you don't need to do it again. So this would be cos pi over 8 plus I sine pi over 8. And you calculate that. That's a number. So that's Z1. Now you do the same thing with Z2. You do the same thing with Z3. And I just don't want to waste time here. Z3. So this is where this is used a lot when you're solving an equation like this. It could be any sort of equation, like yeah, z to the power 4 is equal to -1. Yeah. How can something to the power of 4 be equals -1? And you could do it the same way, or you can do it by factorizing. Actually, factorizing works as well. Oh no, sorry, factorizing in this particular case does not work. But yeah, so z to the power of z4 is another one. Okay. Can we? Okay, through de Moivre's theorem. Right. Could you? Can we use the theorem to approximate pi? De Moivre's theorem. Doesn't immediately come to mind. Like how would you do that? No, not off the top of my head. Not off the top of my head. I'll leave that question out. I'll give it a think. Edward, could hints for problem 14 physics? That's super hard. I'd love to. So let's have a look at question 14 physics. Oh yes. You know, most of the questions I find in old books. For example, a lot of the math questions I take from this book. Okay, and you can see it's an old year 9 book. If you remember your first assignment for quadratics, it was most of the questions are taken from this book. It's a year 8 book. It's just from a different country. Slightly harder material. So we there's Feynman's book, Feynman's lectures on physics. But this question was well, I came up with it myself. So that's my personal favorite. Okay. So what can you do here? Small rest is up smooth. So it goes smoothly. So to find the speed, what would you do? What would you use to find the speed? How to find speed of the mass? Oh, sorry. How to find speed of the mass? Can somebody help me? 613. Yeah, conservation of energy. By all means. Yes, conservation of energy. Conservation of energy. Conservation. Of energy. So at the top, you have MGH. At the top, you have MGH. Oh, sorry, Mg2R. Mg2R. That's the energy at the top. So at this point, you would have less gravitational energy, but you will have kinetic energy. So it's going to be mgh plus a half mv squared. So that's how you find the speed. And then knowing the speed, you can find centripetal acceleration. And knowing the centripetal acceleration, you can find what can you find? Well, you can find the centripetal acceleration. Now, the second question from me to you is, what happens when it loses contact, when the mass leaves the ball. N equals 0. Exactly. N equals 0. So you know everything. N equals 0. And can you just, what kind of motion? What kind of motion? Kind of motion after the mass has left. Parabolic, how do we call it? We don't normally call it parabolic, Yusuf. We call it projectile, of course. Projectile. So I hope that helps. So there are a few things you need to look at. You need to look at the conservation of energy to find the speed. You need the condition where it leaves the ball is normal reaction equals 0. And hopefully that helps. Oh, you need Newton's second law, of course. Yeah, Newton's second law. Right. So I hope I haven't hinted too much, but super hard. There's centripetal mass lose contact with it. If of course there is. Look, you do not have centripetal acceleration as only when you're traveling in a straight line. So if you're not traveling in a straight line, there you have normal acceleration. And you need to figure out what normal acceleration is caused by. So at any point on the sphere, let's say the mass is here. You have the normal reaction, you have the gravity, mg, and you have, well, you need to split this into component, and you are accelerating towards the center because that's what you do. Are all the answers meant to be in terms of R? In question 14, yes. They won't be in terms of R. Look, as a general rule, whatever you're given, so a small mass is a radius r. That means r is given. The sphere is fixed to the horizontal floor at point F. At what height h? So what height h is what you need to find. H is what you need to find in terms of r. Oh yeah, in terms of r. That's it. That's it. All answers in terms of r and g, of course. In terms of r and g. Good. More questions? I hope that helps. For question 2, let's have a look. That was a while ago. Question 12. Ah, yes. No, this is a standard thing. So let's say you are on a slope. Let's say you are on a slope and right. And there are forces acting on you. So there is gravity. Well, not gravity, weight. You're great. The normal reaction force. Normal reaction force. And that's it. And you're supposed to be accelerating downwards. Oh, there's friction. Sorry. Of course, there's friction. There's a friction force upwards. Right. So this is your normal reaction force. This is your friction, and we know that friction when you are sliding, when you're actually moving, is mu n. And this is mg. So in this situation, we make the slope the x-axis, and that's very important. And we make the y-axis goes perpendicular to the slope. So we resolve the forces in the x direction, and we can split mg into two components. Yeah, guys, you're answering the correct things. So yes. And this is theta. This is the angle theta. This is the angle theta. This is mg cos theta. And this is mg sine theta. Sine theta. Now, in the x direction, we have mass acceleration. Mass acceleration is equal to the resultant force. So mass acceleration is equal to mg sine theta minus mu n, which is the friction force. In the y direction, your acceleration is 0. So mass acceleration is equal to 0. And mass acceleration, okay, sorry, is equal to the resultant force. And that's equal to 0 because it's not moving in the y direction. So here we can say n minus mg cos theta is 0. In other words, the normal reaction is mg cos theta. And that's a standard result. Whenever you have something on a slope with friction, this will pop up everywhere. Now you plug this into here. You plug this here, and that makes it ma equals mg sine theta minus mu mg cos theta. Now m cancels. And we want the acceleration, you want to be accelerating down the slope. So if a is greater than 0, if the acceleration is positive, then g cancel. Oh, sorry. Oh, yes, g sine theta minus mu g cos theta is greater than 0. Yeah, that's what we have here. Sorry, g does not cancel out yet. It will cancel out the next step. So g cancels, and we have sine theta greater than mu cos theta. In other words, tan theta is greater than mu. So this condition comes out of this condition. Now, if tangent theta was less than mu, the object would not even start sliding. And if it was sliding, it would slow down. So if mu is greater than tan theta, the object object will not start sliding if mu equals tan theta. Object slides with constant speed, or is stationary at the point of slipping. Is stationary at the point of slipping. And finally, if mu is less than tan theta, it accelerates down the slope. Okay. And that's really cool, because let's say you have a surface like one of my favorite books, and you have a calculator, and you want to know the coefficient of friction. You want to know the coefficient of friction of this. So you start tilting it. You start tilting it. You can actually do it in front of your camera. And you measure the angle when it starts to slide. So this angle. So let's say you measure this angle, and the angle is 75. It's a fantastic experiment, and it's so easy to do. Calculator, actually, you know what? I'll be even cleverer than that. Okay. My calculator starts sliding when theta is 75 degrees. Okay, so that means this angle is 75. Something you can measure. Okay. 75 degrees. Let's not put 75, let's put theta. So coefficient of friction between the calculator and the book is equal to tan theta. As easy as that. Tan 75 degrees, which is tan 75, 3.7. Wow. 3.7. That's an unusually large. Perhaps my angle is nowhere near 70. Nowhere near 70. Let's see. Do I have a ruler? Yeah, perhaps my angle is nowhere near, but yeah, you can find the coefficient of friction by that. Okay. I hope that makes sense. So that's an important one. Yeah, and basically what happens at this point, it loses contact. And starts to move in a parabolic path. So not down the slope, but exactly at this point. So it's exactly at this point, the normal reaction mg mg, and the centripetal force, there's acceleration downwards, and it's just normal reaction is 0. Normal reaction is 0 at this point. So actually it's 0. We don't need to draw it, but you need to draw it and then just make it equal to 0. Okay, so I hope that answers your question. Jeremy, for question 20 in the math, what does the complex number that is at the center mean? Does it move when transformation applies? I believe so. Let me have a look. For question 20 in the math assignment, does the complex number that is in the center? The transformation would be the complex number at the center of rotation. Yes, of course. So basically, it is represents a rotation. So we are rotating around a certain point. So you need to find the center of rotation. Center of rotation. Just like you did in key stage 3 or GCSEs. So you had a shape, and you just put a dot here. You rotate it. And you just need to find the point around which you are rotating. So somewhere here. In this particular case, you're rotating around this point. Hope that makes sense. Does it mean that friction is high enough to stop motion? That means the opposite. Does it mean that the friction is not high enough? Oh, yes, isn't high enough. Sorry, the friction isn't high enough to stop the motion, or friction isn't high enough to. Friction is friction doesn't. Well, basically, the friction is not high enough so that you can move, because if you're on a slope and the friction is too high, you just won't be able to slide down. Okay. Something else? Can I let arc Z and arc B arc B? No, I mean, B is a parameter, so you can say that you can use arc B as in the answer. That's not an issue. Yeah. Your answer can be in terms of B. So it can be in terms of arc B. Problem 15 in physics. Well, the hardest thing is to understand what, I mean, all these fancy words about tensile strength and density and theta, what are we actually looking for? Which physical quantity are we actually really interested in when we want to consider not the centripetal force. When you're answering a question, when the ring breaks, so what do you actually, or why does it break? Well, max angular velocity is what you're trying to find, but if I ask you, will this break or not? What's the first thing that you need to know? Will this rope break or not? Will this ring break or not? The tension, of course. The tension is the most important thing, is a thing that is hidden here. And that's what you need to find. So if you take the ring, okay, just take the ring. And you take a small part of that ring, a really small part of that ring, just like in integration, you take a small part of that ring. And you can give it a name. You can say it's r d theta, for example, where d theta is the small angle here, and that's the length of that piece, theta. And what you need to realize that this small piece is being pulled by two forces, tension and tension. And the resultant of these two tensions, if you take this tension and this tension, and you add them up, this is going to be your centripetal force, F centripetal. Okay, so this is tension, and the resultant. And then you just remember that tension is sigma times cross-sectional area and stuff like that. And density is mass divided by volume. Mass and volume is area times the length of that piece of string, and you can work out something from here. I think I've probably just solved half of it, but you need to put all of this together just to make sense of it. But I hope that makes sense. This is the crucial bit. This is the crucial bit and probably the hardest bit to figure out and give it a go. Okay. What else? As you probably have, as you probably see, I prefer physics questions. Also, maybe because I write the physics assignments and I only have a small input in the maths assignments. Well, not all of them. Some maths assignments I do most of the thing. I do most of the assignment, but recently I just yeah, I do the physics ones. Okay. More questions? Could we do waves sooner rather than at the end of the program? Let me have a look. What's the plan? Actually, Mia, you're making a very good point. Because waves, you study waves in year 12. All right. You study waves in year 12, so that would make much more sense. I will consider that. We might move waves earlier. Waves actually would go very, very nicely after differential equations. Okay, thanks. Thanks for that. That's appreciated. Anything else? Question 14 on maths. Well, this is a very standard one. It's a very standard one. Is that the one that you were wondering? Solution. Look, how I would do it completely differently. Yeah, it's trying to take you modulus and argument method. I would say, okay, z to the power 5 is equal to 1, and z to the power 5 is equal to 1 is e to the power I 2 pi I. So Z is equal to E to the power I 2 pi over 5. And then for n equals, I would just substitute 0, 1, 2, 3, 4 to get the answer. So Z1, Z2, Z2, etc. You get 5 different answers. And that's the beautiful thing about it. And for this one, well, for this one, you do long division. Long division. Okay. You divide this by that. Okay. Or this by z minus 1. And then then you just do that. That's very straightforward. I won't go any further than that. Long division. Okay. Occam was right. Yeah, Occam's razor. Anything else? You can ask all sorts of questions, guys. You can ask how big is the pumpkin that I bought for Halloween, for example. Well, it's big, twice the size of my head. That's my Halloween pumpkin. I don't know. Just wanted to boast a little. Do we get marks back for our assignment? See if we don't get in. Yes, you get the marks will be on Google Classroom. So you submit them on Google Classroom, and you will see the feedback on Google Classroom. If you want more detailed feedback, you can ask us, and we will send you your marked work. Although we have we have 1,600 applications. Well, okay, there's 600 applications for year 13, and there are 1,000 applications for year 12. So we probably won't be able to give like really detailed feedback for every single paper. We just don't have the human power to do that. But upon request, you can get feedback. Is there a mark scheme for the question? Is this nothing or is all or nothing for a question? There is a mark. There's a mark scheme, but the mark scheme. So how I instruct the tutors is how far, how much progress you've made in a problem. Yeah, you might get the answer completely wrong, but still get marks because you were thinking in the right direction and you've put that down. You've used the correct. You've chosen the correct the correct laws of physics, for example, or you went the correct way. But yeah, so you will have. It's not all or nothing, definitely. We won't be able to share the mark scheme with you, unfortunately, but we will be producing answer sheets, so the sheets just containing the answers. Artemis, how long until after we submit? How long until we are notified that we got in? So my prediction is by the end of October. You will know. We'll try to make it sooner, but it's just the amount of marking that we need to do. And because until we've marked every single paper, we can't say who got in and who not. So just be patient, please. It will take us time. We are expecting about 1,500 papers to be returned to us. So about half the people who registered, they actually sent the work in. And so out of 1,600 people, we expect 800 to be returned. 800, but you remember 2 papers each, so about 1,500 papers. Okay. Okay. Right. I want to share with you a basic trick for quadratic equations, because I find it incredibly useful. I know you all know how to solve quadratics, but I just want to show you a trick that I've used a lot in my life. So trick with quadratics. Quadratics. So let's say you have a quadratic, ax squared plus bx plus c equals 0. And you notice that a plus b plus c is 0. Then the first solution is 1, because obviously if you substitute 1, that makes 0. A times 1, b times 1 plus c is 0. And the second solution is c divided by a. So x squared minus 4x plus 3 equals 0. So you notice that it works. So 1 minus 4 plus 3 is 0. So the first solution is 1. The second solution is 3 divided by 1, which is 3. And it works with more complicated ones. So for example, 23x squared minus 16x minus 7 equals 0. You notice that 23 minus 16 minus 7 is 0. So the first solution is 1. The second solution is minus 7 23rds. Okay. If you type the counterpart for cubic squares, well, I mean, if this it's not specific to cubics. I mean, it could be any power, ax to the power 6 plus bx to the power 5 plus etc. If x is 1 is a solution, then the sum of the coefficients is 0. That has to be true. Because if you substitute 1, and okay, put a 1 if you knew this rule. If you knew this rule. Okay. Well, yes, the sum of the roots is minus b over a. True, absolutely. And there's another rule. If a minus b plus c, so if you change the sign of the second coefficient, and that makes 0, then x, the first solution is -1, and the second solution is, I mean, this is practical for quadratics. It's not very practical for cubics. You can devise similar rules for cubics. Is minus c over a. Minus c over a. And let's say we have x squared plus 6x plus 5 equals 0. You can see that 1 plus 6 plus 5 is not 0, but if you make this a minus, 1 minus 6 plus 5 is 0. So because 1 minus 6 plus 5 is 0, that means the first solution is -1, and the second solution is -5. And you can check that it is true. And this works with the harder ones as well. So 20x squared plus 17x plus -3 equals 0. So you can see that if you change the sign, it becomes 20 minus 17 minus 3. That means that x1 is -1 and x2 is minus c over a, so it's 3/20. And this saved me so much time because when you know this rule, you start noticing that like every third quadratic equations that you encounter is one of those, is one of these types. So yeah, use this. Hope that helps. Can you use the centrifugal force to solve problems easily, or is it not recommended? You can for COMPOS. Don't do it for school. I've said this like 17 times already, but I was a marker for one of the exam boards, and they always write in big letters 0 if centrifugal force is mentioned. they are ruthless with centrifugal force, so please don't. It is so hated because you need to be a really advanced physicist to understand it correctly. And as I said, it's an imaginary force. It is a non-existent force. Okay. What was the reaction of the teacher? She wants just to see the reaction. She was strongly against it. Okay. Okay. Yes. Yeah, because you need to be a very advanced physicist to understand it's not a real force. It only exists in a non-inertial frame of reference. And in school physics, you never go near non-inertial frames of reference. You just don't study them. Therefore, this force should not ever be mentioned. And if you're mentioning it, then you don't understand physics. That's what they think. Yeah? They don't think you're so advanced that you understand centrifugal force. No, they think that you've messed everything up. Because this is always mentioned in people who don't know physics very well. They use it a lot. For example, I don't know, race car drivers. I mean, they understand how cars turn. They don't necessarily understand the physics of things, and they always say, oh, it's the centrifugal force that throws you attempts to throw you out of the car, and that's what they experience. But when you try to model this mathematically, then you have to use centrifugal force. Circular motion chapter text this week. No, don't. No, you can't blame that on me, Yusuf. You can't blame that on me, because I've told you 17 times never to use centrifugal force in a school exam. Okay. Right. Okay. Brilliant. Can we use moment of inertia sometime? Moment of inertia. Let me just have a look at the current version of assignment, of the next assignment. Now, next assignment is going to be written by, the next physics assignment is written by an absolutely brilliant student of Oxford student, one of the best. And let me have a look. He deleted it. He deleted moments of inertia. So we'll see how it goes. Maybe we'll include it, but it's a very maths heavy topic. It's a very maths heavy topic, and we felt that it's just going to overload the program. Just going to overload the program with too much maths, which you will learn. I mean, you will learn moment of inertia on the first year of uni. So don't worry if we don't go through that. Bring it back. It's a bit late for that. It's a Thursday, and it's going to be published on Monday, so probably don't have enough time to put that back in. Okay. All right. Well, I hope I don't see any more questions. I hope this session was useful. I'll start a quick test. So duplicate. So how do I duplicate the stuff? Make a copy. Copy. A quick survey, just one question. Did you find that useful? Did you find this Q&A useful? Do you recommend any resources that would help the assignments? So books. Well, but in particular with assignments, I'd say videos. Like if you don't know, try to Google the problem. Try to find the problem in YouTube. Just take the actual text of the problem, go to YouTube, and they will be going through similar problems. Or just or Khan Academy. Khan Academy is brilliant. If you want more general stuff, is three blue, one brown. Great channel. Numberphile for maths. I find it brilliant. If you haven't read Richard Feynman's books, do that. They're absolutely brilliant. So there are books. But by the way, the feedback form is anonymous, so you can be brutally honest. if you didn't find it useful, please do let me know. Richard Feynman's books. It's books about the well, there's a book called Surely You're Joking, Mr. Feynman, and he just explains scientific the way a scientist thinks, which is great. He just talks about his life. It's not a book about physics necessarily. It's a book about a scientist, one of the most brilliant scientists of the 20th century. And there's another book, A Pleasure of Finding Things Out, Richard Feynman, Pleasure of Finding Things Out, which is an interview with Richard Feynman, and he's talking about like simple ideas of physics, and it really gets your brain to start thinking. You can also watch the video, Pleasure of Finding Things Out. Okay. Near December, Oxford interviews. Yes, Professor Lvovsky will be doing a session on Oxford interviews. Definitely. Right. Okay. Well, I hope you enjoy that. Let's see the feedback. Mostly 10, 9, 8, 6. All right. no sevens. Okay. That's good. Right. Okay. So next week we will have a session on gravity and orbits, and the week after we will do differential equations. Oh, sorry. Why did I say differential equations? The other thing, implicit differentiation. Okay. All right. So
can I ask a quick question?
Yeah.
Just about Oxford admissions. How does it work? So I know the PAT is being set on the 2nd of November, and then when do you get to hear about the results of the PAT and whether you get through to an interview? How does that work? Can you like talk me through?
I'm not the right person to ask, unfortunately.
Okay, sorry.
Yeah, I don't know these details. I'll ask, and if I get a decent answer about this, I'll let you know. But yeah, Professor Lvovsky will definitely know more. So if you have a chance, ask him. Okay, welcome. See you, everyone.